Hi everyone, so today's just going to be a quick introduction to procedural audio with Unity, and what we're going to be using is pure data and the heavy compiler by NZN Audio, which is an online tool. So what we're doing within pure data will actually be transferable to Unreal 4, not directly. You would need to use Wise, but I'll be uploading a tutorial about that at some point in the near future. But today we're just going to be going through basic vanilla Unity and vanilla PD and how we can get started with that. So when you get PD, make sure you get the vanilla distribution, because the tool that we're going to be using to actually import that to Unity, the heavy compiler, doesn't work with PD extended's object. It only works with the bare bone version of PD. So make sure you just get this version here. You're also going to want to sign up for an account. I've already done that, and I'll log in later after we've designed our patch, but make sure you have an account for this website and we're good to go. I'd also recommend just typing in pure data and then reference card. If you ever get stuck with anything in pure data, this is a really good tool. It basically gives you a really succinct but accurate description of what each object does, and it's saved my life a bunch of times, so just keep that up. So this is the scene that we're going to be working with in Unity. It's very basic, it's just some trees and grass. So if we listen to this right now, it's just footsteps, there's nothing. I'm actually going to disable this axe at the moment. So yeah, it's just sound effects for your feet, and there's no ambience or anything, but you can see that there is a subtle wind effect. So maybe we could start by making some kind of wind sound and importing that into Unity. So once you start PD, we're just going to create a new patch and we're going to maximize that. So for this tutorial, I won't be going into too much about how the principle of sound design works. I would recommend you read Andy Farnell's Designing Sound. It's a great book. It's got lots and lots of examples, and the chances are, if you're looking for a sound, he'll either have an example of it or you'll have information pertaining to how you create that sound. So I can't recommend that book highly enough. Anyway, so we're just going to get started with some noise generators. This is white noise, which means it's random across all bands. We're going to create a few of them. And what we're going to do is we're going to stack them through some bandpass filters. So we type BP tilde, and there we go, we have our, if I could get it to extend, there we go. We have our bandpass filter. We're also going to stack these. By stacking them, we're able to more tightly control our Q, or how wide the area of effect our filter is having. So we're just going to quickly hook these up to go into the first filter, and you go into the first filter, and you go into the first filter. And in fact, no, we won't do that. So what we're going to do is we're going to do 2 stacks for each noise component. This will let us have a little bit more variation in our wind. So if we adjust the frequencies for each noise filter at different times and for different frequencies, then there's going to be more movement and there's going to be more peaks present in the spectrum, make it more interesting to listen to. So if we open up the help, I'm pretty sure, where's BP? Yes, so the second inlet is for our frequency and the last inlet is our Q. So what we're going to do then is we're going to create a random number, 3 random numbers for now. Just get that up there. Yes. And then duplicate them for Q, so we'll just hook them up. Move it over there, keep it tidier. So you in there. So all we're doing here is just hooking up these numbers to the frequency and the Q for both of the filter objects so that we can get the proper stacking effect. that we want. And one last one here. Okay. So now all we're going to do is we're going to Control 1 is the shortcut for a new object, by the way. If you're coming from Macs, that took me a while to remember. I was double clicking for ages. We're going to use the multiplication tilde object, so multiply signal. We'll multiply it by 0.2 initially, just to get it down into a safe, usable zone, and then we can play about with this value afterwards to make sure that we're getting a good level of sound. So drag every object or each signal into the multiplication. Okay, so, and finally our DAC. So that doesn't sound very good right now. We're just going to quickly play about with some of this before we go. So we'll set the center frequency here to about 180. We'll set this to 240. And we'll set this one to somewhere in between 210. That'll do. If we leave our Q at 0, we are essentially letting the whole audio signal through, so there is no point in having a Q of 0 at all. I recommend in the range of 1 to 8 if you're planning to use your Q. If you want to let everything through for at least for a little bit of time, then it is a very useful tool to just be able to go back to 0 and it's going to let your whole signal in. But for this demonstration we're going to adjust the values of Q for a while. And let's see what this sounds like. So I don't know if you can hear that, but I'll bring up the frequency range a little bit. What would be a really good idea actually for these objects is just set their lower boundaries to 0 and like their upper to 8. You don't really need to go any higher or lower than that. So just do that really quick and it avoids these really unpleasant things. So let's bring everything up a few registers. The basic principle of this is that we've got 3 different ranges of noise. We have a bandpass limited noise at 653 Hz, one at 290 Hz, and another at 570 Hz. If you want to create the swelling for wind in the low end, then all you would need to do is make sure that you had one of these set to a fairly low frequency. So if we keep these ones in somewhat higher frequencies with a little bit of a higher Q, so around about here, and we'll just turn you all the way up so we can't really hear much of that right now. If we wanted to create swells in the low end, all we would need to do is modulate this right here. To get that effect. So we'll go about how to actually affect these values, but for right now we have a basic wind effect. If we took this right now into heavy, it wouldn't work because we haven't actually assigned default values for these objects. So what we're going to do, really just very quickly, is create some messages, some hard-coded messages, and we're going to load bang them as soon as we load in so that we can get this sound essentially. So I'll just quickly write these down. Obviously we'll change this later. 771, and I'm actually going to bring it up like 650, and then so all we need to do now is hook these up to the individual message boxes that they apply to, or the individual number boxes they apply to, my bad. Yeah, so this one goes here and there. We create a load bang and just hook it up to all of this stuff. A good way to test how your sound is going to work in Unity or any application of it, I should say, I'll just call this Win Basic, is to save it, make sure you've got your patch like this, and to just immediately cross out, go away. And if you can go back on, open, and open the file again, turn your music on, and or your DSP on, and it sounds fine, like it does now, you've generally got a good idea that it's going to sound okay when you bring it into Unity. So, that's done. So now we have our patch that we want to use, Wind Basic. Now we go on to the heavy compiler. I'm just going to quickly log in. So I've got a few up here already. So let's call this Wind Effect. And we're going to get our patch file that we just made and saved. So I saved mine to the desktop. I would not recommend you do the same, but here it is. So we open that up and create patch. So if it's successful, which it won't always be, and you won't know why, you'll need to troubleshoot. If I would recommend, if you're using any patches that you didn't create, so for example I was using a vanilla port of the freeverb object, and there were certain things within that, I think it could have been to do with how many sub-patches were used, but it just wouldn't work on the heavy compiler. So if you've got any problems, have a look through what it is that exactly that your patch is doing, and look at every single abstraction to make sure that there's nothing dodgy going on and there's no objects that you're not allowed to use. So this is a full list of ways that we can actually get the file that we just uploaded. So we can get the base PD patch that we just created. We can get its C++ source, which is useful if you're doing anything with Juice. And the rest is just direct ports. So I don't know what Fabric is, but this is the bit that we're interested in right here, the Unity. So I'm on Windows 64-bit, so I'm going to download this one. Might take like a little minute or something. It's awesome, it also gives you like a little preview down here. So this is pretty good. So, where is this? Okay, this is in our downloads. I'll take that to the desktop and extract it. So, what you're going to want to do now is just put this in the folder where your Unity files are. So I've actually already created a folder for the heavy stuff. So I'm going to show an Explorer, just drop it in there. It's going to compile our scripts obviously, because this is real code that's generating sound instead of just a sound effect. So there's Wind Effect. So all we're going to do now is set up an object in the scene so that we can hear it. I'm going to do this next to the player just for demonstration purposes. I'm going to create a cube so we can see where it is as well. That's fine. Now what we're going to do is we need to attach an audio source. You don't need to do anything else with it. Make sure Play on Awake is selected, but that's all we need to do. Minimize that. So to get the sound that you used in PD, all we need to do now is go into the folder that we've just imported and take the C# script that it generated, I should say, and drop that onto the object. Now you'll notice there are no parameters, there's nothing here that we can affect, and that's because it uses Unity's audio source for all of its controls. So if you want to adjust its volume, you use the Unity audio source. If you want it to be spatially blended, so if you want the sound to be spatialized, so right now we're going to leave it at 2D because it's an ambience, but I will show that it works with 3D as well. So there you go, you can hear our wind. It doesn't sound too great at the moment, but it works. So just to show you that we are actually using the audio source, if I change this to 3D, it starts to get quiet as we walk away from it. So next time we're just going to have a look at how we can send parameter values to stuff like how to change which of the bands of noise are swelling the most so that we can create a more dynamic wind. If you really wanted to get insane about this, you could also look at your wind zone settings and maybe try to use some of that to affect your pure data patches. So if the turbulence was huge or something, you might want to create a higher chance of swells and stuff like that. So you can look into all this different kind of stuff, but for now this has been a quick introduction on how to use heavy, pure data and Unity to create procedural audio.